Aktor and Menpolrut, dan fisikawan kuantum NASA, Elliott, mendiskusikan seperti apa dunia kuantum itu dan bagaimana NASA mempelajarinya setiap hari. Perlu kita ketahui bagaimana ilmu kuantum NASA dapat membantu membuka wawasan tentang misteri terbesar alam semesta, sekaligus berkontribusi pada teknologi yang meningkatkan kehidupan kita di bumi dan memajukan eksplorasi ruang angkasa. Kita simak diskusi antara Polrut dengan ahli kuantum fisik NASA berikut ini.
Hi, I'm Paul Rudd, and I play Scott Lang, better known as Ant-Man. In my latest movie, Ant-Man and the Wasp: Quantumania, I get to explore the quantum realm. But what you might not know is the quantum realm is a very real thing, and NASA scientists explore it every day. So, I have a few questions for the team of quantum physicists at NASA.
Hi, Paul. My name is Dr. Elliott, and I'm a quantum physicist working on the Cold Atom Lab, NASA's first quantum science laboratory in space. And I'm excited to answer your questions. But first, what is quantum science? Well, quantum mechanics describes our universe on the smallest scales, where tiny particles can also behave like waves, meaning they can be in two places at once, or they can move through each other. Now, what questions do you have for me?
How does quantum science impact our lives here on Earth?
Quantum science is behind many of the technologies that we use every day, including your phone, computer, GPS, or even MRI scanners for medical imaging. In the movies, you can shrink down and go into the quantum realm. We can't do that. But what we can do is make the quantum realm itself bigger. And this is the purpose of the Cold Atom Lab, which orbits the Earth inside the International Space Station.
Secondly, how can NASA's quantum science help unlock some of the universe's biggest mysteries?
In recent decades, scientists have come up with a new way to study the quantum world. Using lasers and magnetic fields, the Cold Atom Lab can create macroscopic quantum objects. We can amplify quantum effects. And then we put these big quantum objects into space because that gives them more time to interact with gravity, because they're floating in orbit and not crashing into anything the way they would on Earth. And we care about new ways to study gravity because dark energy, dark matter, those are just words. They're names for gravitational effects that we don't understand. And ultra-cold temperatures, they're like a quantum lens that will hopefully one day allow us to see further into the gravitational unknown. Studying quantum mechanics with ultra-cold atoms, these are the hardest experiments that you can do on a tabletop on Earth. And they're even harder to do in space. With the Cold Atom Lab now operating in space, some of the achievements that we've been able to demonstrate so far are creating the first macroscopic quantum object in orbit. We've created the first quantum bubbles, which cannot be done on Earth. And we've recently created two simultaneously existing Bose-Einstein condensates, two large quantum objects with which we can form exotic molecules or perform new experiments of gravity. For everything that we do know about quantum mechanics, there's a lot that we don't know. And space opens up new avenues to explore these. Thank you, Paul, for your interest in this deep dive into the quantum realm. Hopefully together we can inspire the next generation of quantum superheroes to help us continue to explore the unknown.